On the bench today is the NOTADÜMBLE by JHS, and we're going to mod it. Before we can mod this pedal, we have to understand how it works. So I've got pedal connected up to a SIGGEN and an oscilloscope. So the SIGGEN's putting out 1 kilohertz, 300 millivolts peak to peak. And you can see that sine wave is on the screen of the oscilloscope. So let's engage the pedal now. Everything's set to halfway. I'm going to engage the pedal. And we're on the boost section. That's indicated by the green light lighting up on the lower set of knobs. And this looks like a boost, amplified signal, similar to what I've seen in, say, a Beano boost. The bias is slightly off, so the top is clipped off, which gives it asymmetrical distortion when you use the boost. So that's what it's been designed to do. If I just turn up the volume a little bit, this is the volume on the output. You can see there's 6 volts peak to peak, which to me indicates it's not a clipping diode being used in this circuit to clip the top off. It's actually the bias. Now let's switch over to the distortion. So we see the overdrive. So we immediately see a reduction in volume, so we're clipping, so there's clipping diode in there, and that is at 1.5 volts peak to peak. Now, and if we turn up the gain, there's not much of a change until we get to about 10%. So at 10%, it's a clean. And then the clip comes in, and then it just stays for about 80% of the rotation of the knob. I'm going to say, because it says overdrive here, I'm going to say that this is a soft clipper, probably using some combination of diodes to get the right voltage around the op amp. And I'm also going to say it's probably using an op amp to do this. This is probably just a transistor stage. So we've got some basic idea of how the pedal works, and so why don't we flip it over now and take the back off and do a visual inspection. The back is off. It's 2 boards, a ribbon cable. This is called a presence, and I've got a feeling, because in a minute we'll probably go over a Zen drive, because I asked AI earlier what is the best pedal that represents a Dumble, and it says a Zen drive, so we'll look at that circuit. Over here I can see a transistor, so over here I can see a transistor, so I'm going to guess that's the boost. This is power supply filtering up here. Down there is what is highly likely an op amp, and I can see the boards marked as with diodes, D1, D2 or D7 or whatever, and there's a couple of transistors in there as well. So I'm guessing right now, but this is just by visual inspection, that it's 2 diodes and a transistor, probably a FET. The other at the back here as well, that's a FET, I would guess as well. And I'm guessing it's 2 diodes and a FET that make up the soft clipper in one direction. Then the other direction it's just the same. So it doesn't look asymmetrical, because there's an even number of diodes and FETs. All right, so I'm going to remove this board. In fact, I'm going to just take it out of the box completely and disassemble it. And then we're going to put the scope and SIGGEN back on, and we're going to try and trace out some signals and figure out how this thing works. I've got the boards laid out now. It's full of little statements like "Thank you, Mr. Mayor," and "Dumble made his first amp in 1963. Here are the pots. Here's the switch, which I think is going to play an important part in the mod that I've got in mind that we'll discuss. And this is the input board and a switch. So flipping it over, let's just take this out for now so we can see this board. So I'm going to zoom in, and here's let's get this cable out of the way. So this is highly likely a FET. This is highly likely an op amp. Don't know what type, don't care, but they all follow the same pinout, so I'm just going to guess that. I don't want to go into too much detail of the design itself. I just want to be able to do a mod. And then you can see what I'm going to presume is the negative feedback section, which is, what am I seeing here? I'm seeing 3 diodes and 2 transistors, so it is asymmetrical. So that's quite interesting. And there's a cap as well, and that probably goes around the diodes. So that's good. And there's the present. So why don't we just have a quick look at a couple of schematics before we go on. The first search that came up for Zen drive schematic was this guy, so this'll do. It's 2 op amps. This one looks like a buffer on this one, and then you can see there's a soft clipper around the outside here. On this one, it's 1 diode and 1 FET in each direction. This here is what's often called the present, so that is the trim pot on the back. This is the gain pot. This op amp here just looks like it's a buffer. This, I don't know. Oh, it's a filter. So this and this act as the EQ section on the pedal, and then this is the output with some filtering here as well. And I'm guessing this whole thing with all these capacitor networks and how we do the feedback gives it a mid boost, which is typical of this type of pedal. All right, now let's take a look at the boost circuit. So I'm just guessing it's a range master, but it could be a LPB one. But let's just have a quick look at a range master. Here's the range master circuit from Electro Smash. I covered this in another video as well when we took apart the Brothers AM pedal. But this is a high pass filter network, so only high frequencies get to the amplifier stage, and then the gain is determined by this potentiometer and this resistor, and then straightforward output. And there's also an input, and from looking at the documentation, that the input pot, I'm gonna guess, plays with this network round here, because it mentions something about it changes the frequency response slightly. I'm not going to go into how it works, because I think that's the IP of JHS, but I'm guessing that pot that's marked input does something around here with this filter network. Okay, so now let's get the scope on the circuit. And so SigGen is coming in here. And then if I just go on here and you look on the screen, that is the signal that comes out of the signal generator. The red light is on, so the signal, this switch is probably switching directly between here and here, or when it's pressed in like it is now, the signal goes to this switch here, which then allows us to select either boost or overdrive. So if I go, I've looked up the switch in advance, so I know it's got 4 poles, and so this is the input pole, and this is the output pole, and nothing is coming out of that, so we have to turn something up or down. I'm on the boost, which is the easiest one to understand. So boost is in. Yeah, there we go. So this is the input pole. That is the output pole. And no signal here. So I'm guessing that when the switch is in the other position, this is what feeds the distortion. And we've got some more stuff here. If I put the scope on, what do we get? Nothing. 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 Oh, what was that? A little bit of signal. Interesting. And if I put it here, what do I get? Nothing. And a little bit of signal. So let's try. I'm going to use the multimeter, I think, and try and guess or determine what the second half of the switch does, and these two poles. Here's my multimeter probe, and I've got it set on the resistor setting, or the resistance setting. So I'm going to go to this middle pole here, and that is set to ground. I'm going to go to this one, and that is also ground. So whatever we're doing with this switch, we're grounding either this side or this side of the signal that's going or coming out of the switch, or passing through the switch, or whichever way you want to say it. Let's go to voltage, because I suspect there's got to be some control of the LEDs. Yeah, and that's 7 volts. And that is 0 volts. And then if we switch it in the other direction, and now that's 7 volts. So this part of the switch is the voltage control. So we know what this side of the switch does, the top part of the switch, and we know what one half of the bottom part of the switch does. Just got to figure out what this one does as well, because it'll probably be important to understand that as part of the mod. We now know what 3/4 of the switch does, so let's just try and figure out the last part of the switch. And we know that the pole of the switch is ground. So if I touch here, that looks like it's grounded. If I touch here, that looks like the input signal. Yeah. And then if I switch the switch in the other direction and touch the switch here, that looks like the input signal there, and it's gone from here. So when the switch is in one position, we're grounding. And if I can see here, there's a track. You probably can't see it because of the lack of light, because I wanted to show you the oscilloscope. But there's a track that goes to the boost circuit. So I'm guessing what this does is ground the unused part of the circuit. So if you're using the overdrive, we put the input of the boost down to ground. That's what I'm guessing right now. But as we go further through this, we'll figure it out. And now let's talk about what mods we would like to make. Well, the easiest mod is to take the switch out and replace it with a foot switch. We're a pole down though. We're a pole down with this guy, but I'm not going to do that mod. I'm going to do a different mod, I think. I'm going to make it so you can have the boost drive the overdrive. This is what we're going to do. We're going to add an extra switch called S2, and so when we're in boost, S1, which is this switch here, will be in this position. It'll go through the boost. When S2 is closed, it will go straight through and then down through there. And then if for drive, S1 goes like this into the overdrive, and then back through S1, and S2, the second half of S2 is open when the first half of S2 is closed. Now let's keep playing with that. So now we have the boost on, and then we've switched S2 into its second position. So now it goes around there, through there, and into the overdrive. And S2 is now closed because that one is open, and it goes round and to the output. So now if we select drive here on S1, S2 will have some loading impedance on here, so we'll get a slightly different sound, but let's just see. And then it goes through and it goes out, and the position of S2 here doesn't really matter. So I think I've covered all the switching combinations, I hope. And so now I'm going to have to do some stuff to the pedal. And one of the things is I cannot do this or any of this if the second stage or one of the stages is inputs is grounded while the other one's being used. So first of all, I've got to get rid of that switch position that grounds the input that's not being used. and hopefully it's not going to have, it's a good engineering practice, but hopefully it's not going to have any impact, but we'll have to find out. But I can't do it without it. May get some extra pops, not so sure. I've got my prototype all wired up now, and what you can see on the screen is the boost. So the red switch you can see in the foreground, that it changes the mode of the pedal from the parallel or the switchable parallel to the in series. And what we're going to do, well, let's first of all just check it works. So that's overdrive and then back to boost. And now let's engage this switch. And now we're overdriving, or we're driving the boost into the overdrive. So we see an attenuation there. Oh, wow, look at that. Loose wire somewhere. So that's the volume. That's the volume of the boost. So that's driving the signal into the op amp. And that's the volume coming out of the op amp. And I think this one will be the gain, yeah. Interesting. So why don't we now hook in the guitar? It seems the signal looks correct on the scope, so let's plug in the guitar and check it actually sounds good. I've got the guitar now hooked up. Clean sound, so let's engage the pedal. We're on boost. Sounds good. Let's switch over to the gain section, the overdrive I should say. Very mids, which is expected. Now let's switch over to boost in front of overdrive. You can hear the gain already. Fantastic. So that's all worked out. We've got our switches in place. When you have the second switch engaged, the new switch engaged, so they're in parallel, and you just switch over to overdrive, the buffer affects the impedance there. So if I flick over to overdrive, so the output of the buffer is loading the input of the overdrive. And I think if I move this, which is a volume, yeah. So it's not the output of the buffer, it's actually, we now have potentiometer on the input of the overdrive. You know, we don't have infinite switches and I'm not doing relays. So that I'm calling an extra feature of the pedal. If we disengage the parallel switch, we get back to our regular overdrive. An extra sound for free, I would say. Okay, I'm going to button it up now, clean everything up, put the switch on. Don't know if I want to put a toggle switch or a foot switch on yet. If I do a foot switch, I feel I'll ruin the NOTADÜMBLÜ logo. If I do a toggle switch, I'll not be able to control it. It'll be a fixed pedal, and so it's a set and go kind of thing, and not adjustable by your feet. But let's see how it ends up in the next clip or so. Okay, I've hardwired everything in now, so I decided to go for a switch on the side. Everything looks neat. A bit of select hot glue to keep things mechanically sound over time, and let's plug it in. Alright, we've got the guitar hooked up. Clean sound. Boost. You can hear that clip caused by the biasing, and then just turn it up a bit. That drives the amp a little harder. And that's that filter. Seems to add more warmth the more you turn it up. Okay, now let's go to the overdrive. It's overdriving. Turn up the drive a little bit. Okay, sounds good. Now let's put these two in parallel. So I just want to point out that I wired it so both the lights come on. How cool. So that's it. It's a complete mod, and I'm happy that I've been able to modify a JHX pedal. I'm going to put a Calsonic sticker on it. There it is. And let's consider this a good mod.